Hypertrophy, or muscle growth, has become a popular goal for many individuals, including both men and women, over the past decade. Resistance training has become increasingly accepted as a means to achieve hypertrophy, not only for aesthetic purposes but also for overall health and wellness. To induce hypertrophy through training, several stimuli are necessary. While hormonal and nutritional factors play a role, focusing on training-specific factors. In terms of training precision, hypertrophy training requires less precision compared to power and strength training. This means that small variations in training parameters, such as rep range or rest time, are less critical for inducing hypertrophy. To achieve hypertrophy, training must be done with specific intent, style, and within defined parameters. If these parameters are not met, the outcome will not be hypertrophy. This explains why various training styles can be effective, as the driving force behind changes in strength and power is specificity of adaptations. Unlike strength and power, hypertrophy is driven by a broader range of factors, offering more flexibility in training approaches. The classic understanding is that muscles must be challenged to adapt and grow, and nutrients must be available to support this growth. Focusing on the training aspect, it ultimately comes down to activating cellular mechanisms. To induce muscle growth, a signaling cascade must be triggered, strong enough to stimulate the nucleus and initiate protein synthesis. This signal can be achieved through various combinations, including a single, intense stimulus, frequent, moderate stimuli, or a combination of both. To avoid failing, one can either train with sufficient intensity, once or twice a week per muscle group, or opt for higher frequency training, provided the intensity is manageable to maintain that frequency. The only ineffective combination is infrequent, low intensity, and low volume training. As long as one of the three variables, intensity, frequency, or volume, is high, muscle growth can be achieved. This is because the mechanisms that activate the signaling cascade for muscle growth are diverse. This is also why alternative methods like blood flow restriction training, BFR, can be effective, even with low loads, 30% of maximum, and restricted blood flow, as long as taken to fatigue failure. Blood flow restriction training, BFR, can induce hypertrophy despite using low loads, 20 to 30% of 1 rep max, because it causes metabolic disturbance. In contrast, using higher loads, e.g., 8 reps at maximum weight, induces hypertrophy through mechanical tension. There are multiple paths to achieve hypertrophy, including metabolic disturbance, mechanical tension, and muscle damage/breakdown. However, these mechanisms have a saturation point, meaning that not all three are necessary to achieve hypertrophy. None of the three mechanisms, metabolic disturbance, mechanical tension, and muscle damage/breakdown, are absolutely required for hypertrophy. You can have multiple mechanisms in a single session, and muscle breakdown is not necessary for growth. Having at least one of these mechanisms is necessary, which allows for flexibility in programming. Crafting a hypertrophy program is relatively simple, as long as you ensure you're doing the work and meeting certain standards, such as exercise choice. To induce muscle growth, a strong or frequent signal must be sent to the nuclei to justify allocating resources. Two essential resources are required: amino acids as the building blocks and carbohydrates as the primary energy source to power protein synthesis. This process requires energy, as it involves forming new bonds between atoms, making it an endergonic process. The nucleus must be convinced to invest both energy and supply, amino acids, to initiate protein synthesis. There are various ways to obtain energy, but amino acids are scarce and essential for numerous critical functions beyond muscle growth, such as immune function and red blood cell turnover. The body must prioritize allocating amino acids, as committing them to muscle growth makes them difficult to reclaim and reuse for other vital functions or muscle groups. This process is called protein redistribution, where the body takes protein from one area, such as the upper body, and reallocates it to another area, like the legs, in response to training and insufficient protein intake.